think that does it for the seats. Does anyone, there's still 2 seats back there. Take like one more. So does anyone know what's the high score on the South Park Smart Card game? Does anyone know that down the trade show? Have you been over there yet? It's one of the companies down there has this little smart card they give you. You got to answer trivia questions about South Park, and then if you get the trivia questions right, you get to play this game. And if you get the high score on the game, you get some South Park Beanie Babies. So for those of you who have kids, you probably know what those are. And then the other one you get is a digital camera. It's your choice. So I thought that was pretty cool. I was going to see if I could have a chance to beat anybody. Yeah, how many people here watch South Park? Two of you? Yeah? All right. You want to play on me? Yeah, we were meant to, developers are meant to be heard, not seen. There we go. And probably need to have someone focused on that right hand right. I think they're asking us to focus on the right, on the barcode. I'm not sure what you think. Well, why don't we go ahead and get started? I'll wait for the tape to queue up here. Okay. I'm going to first ask you a couple questions, and that'll let me know what you guys want more of. Now, this talk normally runs out to 75 minutes. So I'm going to give you your choice. Do you want me to give you more information and then answer questions outside while the next person's coming in? Or do you want me to do basically cut it short a little bit and answer questions in here? How many want me to answer them outside? Okay, I got to answer that question. We'll go the full time. Okay, how many of you are currently creating COM components? This should be a pretty obvious question. Good number of you. How many of you are using ATL? Good number of you. How many of you are using the new Visual C++ 6.0? A few of you? All right. Well, as I'm sure you're aware by now, I mean, every conference we seem to drill this into you, COM is the glue that makes everything work. If you look at the Windows DNA architecture, support for MC5, things like that, it's all based around COM. Well, the Visual C++ team has known for quite a while that the places where we're putting our developers at, or places where companies are putting their C++ developers at, are mainly in creating high-performance COM components to meet their particular needs. Now, COM is a great way to deliver both services and UI, but it also needs to be small and fast. The reason being is as over time, as your system grows, you need to scale up to handle more users or more load on the system. Well, fortunately, the Visual C++ team, about a couple of years ago now, looked at this problem, and our answer to it was called the Active Template Library, or ATL for short. Now, ATL has always been designed to create the smallest, fastest COM components. In fact, we can get a COM component down to as little as 5K using the Active Template Library. by really focusing on performance. Now, the one thing about ATL, though, is when it came to kind of a decision between performance and ease of use, we always went for performance. You can always make up ease of use, but you can't always make up performance. Now, fortunately, in Visual C++ 6.0, we've done some new feature enhancements to make a lot of your common tasks while creating COM components much, much easier. Good afternoon. My name is Lon Fisher, and I'm a developer in the Visual C++ team. And if you're interested in learning more about how to create COM components using ATL and Visual C++, as well as learning some of the new features in 6.0 to help you create those components, then you're in the right place. Now, if there are three things I'd like for you to take away from today's talk, it is that, first of all, if you want to create small and fast COM components, C++ and ATL are a really good solution. We've done a lot of work to eke out every last ounce of performance that we can, and that helps give you a head start when creating a great COM component. Secondly, we've made some new feature enhancements to ATL itself, namely the addition of things like windowing and composite controls. And then finally, we've also made some enhancements in Visual C++ 6.0 that makes a lot of your tasks easier. In fact, during some of the demo today, I'll point out things that we've done that can often save you 10, 15, 20 minutes at a time just creating a simple COM component or using a COM technique. Now, what I plan on doing is just running through a very few couple slides, and then I'm going to get into code. I want to try to spend as much of the time in the code as I can, because that's what you're all here for, right? Now, I got the code for the demo out on the, will be on your DVD, so you can take a look at it afterwards if you're interested. What I'm going to do is focus more on the active control side today, more so because it shows more of the new things that we've done in ATL and things that you can take advantage of. Now, I will be pointing out several locations where you can use a particular technique throughout any type of COM component that you may wish to create. Now, we're going to spend most of the time in the demo, and I'm planning on running right to, 3:45 for the talk, and then I'll answer questions outside, because that's what you guys told me you want to do. So let's go ahead and get started. Before I get too far into this, let me do a quick survey of what types of COM components you're creating. How many of you are creating COM components that have no UI? Good number of you. How many of you are creating active controls that do have a UI? Few of you. How many of you are creating components that are using MTS? So transactioning, things like that? Okay. That'll help me focus more on the content as well. Now, let me give you a couple of common definitions so we're all on the same page with regards to what types of controls we're talking about. As you know, there are a lot of different types of COM components, so it's really helpful if we differentiate them up front. Now, to me, there's really three types of controls. The first type is what I call simple controls. And by the way, these are my own definitions. Simple controls have no user interface. They're merely what you use to provide services using COM. Whenever you want to do this, you can use it in any container that's capable of calling co-create instance. So any application that understands how to do a co-initialize and a co-create instance can use a simple control. Now, the second type of control is what I call an active control. And you'll sometimes hear me refer to these as OLE controls. We love to change terminology in marketing every now and then. They used to be called OLE controls. But active controls have a user interface, and they can provide end-user feedback as well as providing services to the user. Now, the difference about active controls and simple controls is that you must have a special type of container to host these. Specifically, you need a control that supports the OLE control or active control interfaces. And we'll talk a little bit more about that in the next slide. Now, finally, the last type of control I'll talk about is what we call a light control. Now, a light control is specifically optimized to run with Internet Explorer. And this is more of an ATL term or an ATL option that we provide you. And what we allow you to do is create a control that only runs with ATL, whether it performs just a simple comm service or whether it provides UI. But the end result is you get something that's smaller and faster that only runs in a particular container that may not work in other containers. Now, as I said, I'm going to talk a little bit more about active controls, mainly because there's more things that I can show you along that path. Now, with active control containers, as I said before, you need to have an application that supports special interfaces. And there are any number of these particular applications available. All of your visual tools will support these. Microsoft Office, Fox Pro, many of the other different applications. The one thing I will say, when you're creating a user interface in an active control, be sure you test that control on a number of different containers. Each container will behave differently. So expect to find differences in your code. One of the most common things I find from customers, they'll have a control that works in application A, they insert it into application B, and it defaults. So you need to make sure you test with a wide variety of containers. Just that word warning up front. Now let me talk a little bit about ATL. For those of you who are not familiar with ATL, ATL is a templated library that creates only COM components. So we don't do a lot of anything else. You won't find like string handling. You won't find like GDI support. You will find just things to make the smallest essential COM components. Now because of this, we have a very small code size, a very high code speed. One of the things that we found is that COM interfaces tend to be orthogonal to each other. There's some exceptions to that rule, but in general, the implementation for one COM interface usually doesn't depend on another COM interface. There's some exceptions to that, but normally this is the case. Because of this, we're able to use techniques such as multiple inheritance and also templating to reduce that code size. The idea is we have a very small and flat hierarchy as opposed to a very deep one, say as you would get like with the Microsoft Foundation classes. So a lot fewer, a lot less depth. And what that allows us to do is to make you only pay for the code that you want to use. That's very important because, if you're creating a small control or small component, the last thing you want to do is lug around an interface that nobody's ever going to call. Right? You only want to have the smallest amount of things on your particular control. Now, we also provide a lot of support for active controls, and we provide that support based on the specifications. There's two specifications based on the year they were released, the 94 and 96 specification. Rather than going into all of the differences, I'm just going to say one allows you to create window controls, that's the 94 specification, and the 96 specification allows you to create windowless controls. And the reason why windowless is important, it can save you up to about 30% of instantiation time when you're creating a control. And I'll bring up some examples of that as we go through the demos. The new thing that we've added, and this has been a popular request from our customers, in ATL 3.0, we've added in support for composite controls. These are controls that can host other controls. And during the demo, I'll create one for you, but essentially it works just like a regular dialog application. So you learn one paradigm and you're able to reuse that. Now, one of the big things about ATL is that you don't require a runtime library. You can statically link everything within ATL. That means when you're redistributing a control or a component, you only have that component to send to the user. Otherwise, you might end up having to ship along, say an MFC DLL or a VB runtime DLL or some other runtime library that you have. When you're installing that, then you get the fun to try to check versions, which version does the user have, and then go ahead and install it, make sure it's all reg-servered right. The nice thing about ATL, just download the control, reg-serve it, and you're ready to go. Now, what I'm going to do, I'm going to switch over, and we're going to do some demos here. And what I'm going to do is I'm going to take you through the process of creating an active control. And an active control has four main elements, which we'll cover: properties, property pages, methods, and events. Properties, for those of you who may not remember or may not be familiar with this, essentially represent data members within the control. A method would represent a function or an operation that you wish to perform. An event is an asynchronous communication back to the container. And a good example of that is a Windows button. Whenever you click on a Windows button, it sends a bn_click message back to its host. That bn_click message essentially represents an event from the control. We're just giving it a fancy name. The final one is property pages. And property pages allow us to specify some sort of user interface for the user to set information on that control, usually at design time. I'll talk a little bit about the trade-offs. One of the things I'm going to try to cover as we go through are some performance enhancements that you can make that will help improve the performance of your components as we go, as you develop them. Now, this should look pretty familiar to you, right? If you want to create a COM component, you do it in two steps. You first create the project using the ATL COM app wizard, and that just creates a project, whether it's a service, an executable, or a DLL. And we've made some enhancements as well for that using MTS this time. And then you come back to your project, and then you insert your controls. You do that using the ATL object wizard. Now here, we've made a number of enhancements in ATL 3 and in Visual C++ 6. I'm going to cover a lot of those. Some of those I will cover in other talks this week. So I'll kind of give a plug for those as we go. Now, let's go ahead and create this control. And specifically what we're going to do is we're going to create just the default active control. Then we're going to add in drawing code. We're going to add in a message handler. We're going to add in some properties, methods, and events. And then we're going to go ahead and create a composite control, which is going to be a separate project, and that's going to use that first control that we create. So let me switch over and see if I can get this demo machine, or the code here. Yeah. Now what I want to do is have this screen here kind of showing the current set of slides, and that machine showing the code. Now, if any of you, I know clear in the back there, if you want me to increase that font a little bit, you want to? Good, okay. I went back there last night, and of course I used glasses that could pass as Coke bottles. Let me just bump that up a bit. That'll hopefully a little bit bigger. I'm going to play the game between trying to keep as much on the screen as I can and make it big enough for you to see. Now the first thing we're going to do is create a new project. And as I said before, we use the ATL COM app wizard to do this. And I'm just going to call this project test, I don't know, let's just call it my test. Just an arbitrary name. And it's going to bring up the ATL COM app wizard. And this should look pretty familiar to all of you, but I want you to notice the bottom checkbox on here, which says support MTS. Now, one of the things you might know, if you're doing a lot of MTS development with ATL, you always seem to run into this problem that whenever you rebuild your control in ATL using Visual C++, you seem to have to go back and re-register it with the MTS Explorer. The reason for that is that the MTS Explorer uses some different registry keys than what we spit out with the ATL COM component. Clicking on that checkbox basically changes how we're going to do the registry a little bit. So once you register it with the MTS Explorer, it stays registered. That's kind of a common nit that I've always had with the previous versions. This will allow you to keep it registered. Now in this case, I'm just going to create an active control. So I'm just going to click Finish. I'm going to go ahead and create the project. And at this point, all we have in here is this code to represent our particular project. So we have the code for just the DLL canon load, DLL get class object, register server, and unregistered server. There's no controls in there. Now here comes the fun stuff. To actually add a control in, I use the ATL object wizard. And for those of you who are not familiar with this, let me move this up towards the top so you can see it better. We've added a lot of new things in ATL 3 and Visual C++ 6. Probably the biggest one you'll see is there's another tab on the category list for data access. Now, for those of you who may not be really familiar with databases, there's a strategy out from Microsoft called Universal Data Access. And part of that strategy is OLADB. Guess what? Basically common databases put together. Kind of a perfect application for ATL. So we went ahead and added a lot of support in for OLADB this time. And you can use wizards to help get you started with that through the ATL object wizard. I'll talk more about these both tomorrow at 5:30 and then at Wednesday, I think at 4:15. So you look for OLADB consumer development and OLADB provider development. Okay, I'll give it my pleasure. Now, the second thing you'll notice is we go back to the controls tab. This is where we're actually going to create our control. We've added in support for composites, HTML controls, and then also light versions of each of those controls. As I said before, light controls are specifically optimized for Internet Explorer. Now, in this case, we have an opportunity to create controls that work just like HTML controls. That can be very handy to you. In fact, I've got a little example up here. And then we also have just regular controls. Let me go ahead and create just a regular control, and I'm going to make it a full control because we're going to use it in both Internet Explorer and the active test container. Now I'm going to call this one, I don't know, PDC test. Put in some name. And this is just an arbitrary name. And then I'm going to select another tab on this dialog box, and it's going to allow me to do attributes. Now, here I want to spend just a minute or two to tell you about some of the things in the attributes tab you may not be familiar with. First is the threading model. How many of you are really considering yourselves COM threading gurus? Don't worry, I don't either. COM threading can be really, really fun because we give you so many different options. Let me give you just a couple points, and you can read a lot more about this. Don Boxich's Essential COM book goes through this in great detail, but kind of my take on this is, if you're going to create an active control, you want apartment threading. The reason for that is, as an active control, you may have a window, an H-win, right? You all remember those back from the old SDK days, right? An H-win. Now, because you have an H-win, you essentially you only want to have one person at a time changing the state of that H-win. To give you an example, it wouldn't look very smart if we had 3 or 4 clients working on the same H-win, all trying to set the font to a different font. Right? It would basically be very, very confused as to which one you get. By doing an apartment thread, you prevent things like that, so you have only one user setting the font or the color, as the case may be. It's kind of that nice little intermediate between single and free-threaded. Now, if you are creating a non-UI-based COM component, you generally will want to use both for threading. There's a little tab on here. It's grayed out right now. It's called both. And both allows you to work both on either single or apartment thread or multi-threaded based upon the apartment it's placed in. If you have a single-threaded apartment, it works as you expect. If you have a multi-threaded apartment, it'll work as you expect. That generally tends to be the most flexible option. It's really a little bit better than fully free-threaded because you get that little bit extra flexibility. So, Ron's rules, active control, apartment, service component or COM component without UI, both. Now, second thing, on our particular demo, we're going to click on a box down here called Support Connection Points. How many of you are familiar with just connection points in general? Good number of you? For those of you who are not, connection points allow you to provide communication from the COM component to its container asynchronously. Events just so happen to be built on connection points, So we want to click this to help us out. But if you want to use something like an outgoing interface or create connectable objects, essentially objects that send information back to their hosts, you'll also want to click on this. Now, the last thing over here, how many of you are familiar with the free-threaded marshaller? This is kind of a strange little thing. You might be asking yourself what this is. The free-threaded marshaller generally helps you out when you're using apartments. And the scenario kind of goes like this. My COM component is created within an apartment, and then I hand an interface pointer to myself to somebody in another apartment. Now, in this particular case, both apartments are in the same process space. So you have like one XE, but you have multiple apartments within that. Now, in this case, what you normally have to do, the standard COM rule is, whenever going between apartments, you must marshal. Now, for those of you who are not familiar with marshalling, generally what that means is you create a buffer, put a bunch of data that represents input parameters or output results or whatever, pass it through a buffer from point A to point B. That can take a little bit of time. Now, in the case where you are both in the same process, however, you're both working on the same memory, so you don't really need to do that. By clicking on the free-threaded marshaller, we'll essentially know out that marshalling code and make it work as a direct function call. This is a nice thing to click on when you use that, when you set your threading model to both, and you're a COM service component or a UIless component. What that means is if someone has you in multiple apartments, communication between those apartments will run much, much quicker. That's just an interesting thing to know. Now, let me spin back to the demo, and I'll talk a little bit more about what we're going to do. Now, as I said, we're going to support connection points to handle our events. The last thing I'm going to do here is on our stock properties tab, I'm going to go to our add a stock property for the foreground color. Now, essentially what our component or our control will do is it's going to display some circles within the component, and we'll be able to change the color of that component based on the foreground color. Now, these stock properties are properties that are so heavily used that we've already just predefined them, what they should do, what they should be. We provide implementation for them already, so when you want to support one of these things, you don't really have to worry about it. You can just go ahead and get in this case, the foreground color directly and use it as you wish. Now, there's some other things I don't cover in this particular example. We have a miscellaneous tab here, and that's where you can select things such as, I always need an H-wind. Now, remember how I was talking about the OC94 and OC96 specifications? Basically, windowed versus windowless. By default, when you create an active control using ATL, we will try to make you windowless if the container supports it. Now, there may be cases, however, where you always need an H-wind. A good example of this is a Windows timer. If you wanted to set up a Windows timer, you generally need an H-wind to attach that timer to. In that case, you can click on things like windowed only, and that will mean even if the container supports windowless operation, we'll still go ahead and force the container to give you an H-wind or to create you with an H-wind when you are instantiated. It's a bit slower, but sometimes you'll require that. Additionally, if you want to make your control based off of a standard Windows control, edit control, static, combo box, whatever, you can do that by using the subclass combo box on this tab. In this case, we're going to provide all of our own custom drawing codes, so we're just going to leave this blank. Let me go ahead and hit OK, and it's going to generate some classes or some code for us. And let me very quickly show you what this code is going to do. And let me first go ahead and do one thing. Because we're going to be changing this a couple of times, I'm going to go ahead and set the incremental compile. Basically means we'll compile a little bit faster, and I'm going to start the compile off as the lights spin on. Wow. Let me go ahead and start that compile. That F7 button really has a good effect on it, doesn't it? Now, one of the things I'm going to talk about here, how many of you are not familiar with multiple inheritance? Okay? So hopefully all of you understand that multiple inheritance, or just in this case, deriving from multiple classes. In our case, ATL derives from several different classes, and each of these classes represents an interface that we implement. Now, the way to understand the taxonomy, if you will, say, for example, iPersist, stream, and init impl. That means it's the iPersist, stream, and init interface, and then we add the letters IMPL on the end of it so that we can go ahead and provide our implementation. Whenever you want to inherit from an interface that we support, it's interface name plus IMPL. The next thing, remember how I told you that the active template library, you remember the templates in there somewhere? We always pass, generally, the name of the containing object, in this case PDC test, we always pass that containing object in as a template parameter. Now the reason we do this is for what we call static upcasting. Now, for those of you who may not be familiar with this, what it allows us to do is to get access from an interface implementation either to its containers, data members, or to data members in another interface. Now remember how I told you there were some exceptions to that rule, that not all interfaces were orthogonal? This really helps us out with this. Now what we do is we pass the name of the class in as a template parameter, and then we cast that to this pointer. So essentially from our interface, it appears as if we have a pointer to the entire object. From there, we can go ahead and access data either from other interfaces or from the object itself. The reason why this is useful is it saves us from having to have a very large and deep class library hierarchy. That saves code, decreases code size, and also increases code speed. So it's a very useful technique. You may want to take advantage of that in your own applications if you wish to do so. Now, I'm just going to very quickly mention these top three classes: CCOM object root EX, cstock prop impl, and CCOM control. The CCOM object root EX, that class is ATL's class that makes this a COM component. All ATL objects will have one of these in it. That implements your INknown interface, implements all of your address release query interface calls. It also handles the various threading issues, depending on which threading model that you select. It's kind of like the C command target class in MFC, if you're familiar with MFC. The third one here is a CCOM control. That actually makes us a COM or an active control. That implements all the necessary functions for us to spin up as a COM control or active control and be recognized as such. The last one is cstock prop impl. That one is for our foreground color property. Remember we added that foreground color? This is the implementation for that foreground color property. So we already do that for you. As I said before, this is already done. Now let me show you what this control looks like. How many of you have ever used the active test container before? How many of you how many of you have ever asked for the source code to the active test container? A few of you? By policy, we never handed out the code to the test container because it was very scary. I think myself and one other guy were the only ones who knew what that code actually did. We didn't write it, of course. Yeah. So one of the things we did for 6.0 is we went and rewrote the active test container so you can actually take a look at the code now. And then we also enhanced it with a lot of new features. You now can add in macro and scripting capability to actually script through control scenarios. Now in this case, I'm going to go ahead and have our PDC test class that we created. I'm just going to hit OK. And this is a pretty simple control. It doesn't do a whole lot for us. It just comes up and prints up a little message. Now what we're going to do at this point was we're going to go ahead and implement the drawing code. And we'll recompile that and I'll show you what that does. Now in our drop down here, I'm just going to select the on draw. And I'm going to go ahead and just replace the implementation. kind of took the short way out on this one and just had this in on file. Let me show you what it's going to do. Now what we do here, first couple of things, we deal with our colors. Now, first of all, we ask our container through the get ambient back color, what's the container's background color? Essentially what this allows us to do is find out which color our container is using so we can make our control look the same. So in other words, whenever we paint this control, it will look like the backgrounds match. The second thing that we do is we take the foreground color, that property we added, and translate that into a color rep. Now one thing you'll notice here, ATL doesn't provide really any GDI support for you. You'll do all of your Windows programming directly. In fact, I've got a bug in this particular drawing code, and let me know if you spot it. There might be others, but I know of at least one. Now what we're going to do here is we're just going to paint the background, and then what we're going to do is we're going to go through and draw several circles in that bounding rectangle. The number of circles will be represented by a variable we add called m_n elements. That's a short describing the number of circles we'll draw. We use the standard ellipse function to go ahead and draw those. And now does anyone see the bug? It's right up here. Yep, that's exactly it. Notice I don't have my delete object in there. Down at the bottom, I'm not restoring the device context to its original state. One thing you need to remember with ATL is you're using your base Windows SDK programming. I hope you have not thrown away your pencil books, right? You'll find them very, very handy. In this particular case, we just go through and I'm just going to leave it because I'm a lazy bum. But you just go ahead and put in delete object, I think in this case like hfull and one other, hback and h4. Now as I said, we need to add in an element here, or things that represent the number of circles. I'm just going to add this in, elements. Now let's make this a protected variable. And I'm going to go in and by default set this to 4. Now hopefully if this all compiles for me, I'll go ahead and bring this up again. Go ahead and bring up the class, and I have nothing. Excuse me? I deleted my ellipse code? Oh, great. Warning, coding ahead. Wow, I sure did. Well, it's easier to do that. Okay, there we go. I always get at least one good banger for each demo. Hopefully that's it. Let's try this again. There we go. So we just have our 4 circles. Nothing too exciting at this point, but just 4 circles. Now what I'm going to do is I'm going to add in some support such that when we click on one of these circles, we'll put up a message box, and we'll have a different message box if we click outside of the circle. And the way we're going to do this, if you look over at my slides here, we're going to add in a Windows message handler, and this is one of the first things that we've done in 6.0 to make this easier. Now, what we're going to do is we're going to do 2 things here. We're going to first add in a Windows message handler, and then we're also going to add in an override to one of the methods in the interface to actually get a variable that we're going to use. So let me first deal with the Windows message handler. Now, one thing in 6.0, always, if you want to see if something exists, a little example here, click on your class in the class view, then right-click on it, and you'll find some new goodies. First one is we have now support to add in the Windows message handler. The nice thing about this is it just brings up a dialog with all the Windows messages. Now, this can be really useful for those of you who don't remember that the function tag for a message handler is like lresult, and it has a wparam, an lparam, Before that, a uint for the message, and after that, a bool to see if it's handled. So if you don't remember that, you just go in here and take the easy way. So I'm going to find L button down. Here we go. I'm going to go ahead and edit that. And there we go. Let me show you what we got here. It's basically gone ahead and created this message handler for us. Now, normally, if you look over my slides, it'll say use the ATL message map and the control. Because we use that little wizard, if I go find this, we've already added that map in, or already added that entry into the message map for us. Each active control, by the way, has a message map to reflect all the windowing operations you want to perform. So in this case, it's already hooked up for us, which is a common mistake I always make when programming without that wizard. Now, I'm going to go ahead and insert. All right. I put some code in here, and let me explain what this code is going to do. And there's also a couple errors in this code for 6.0. Some of these are basically related to the compiler being a little bit more strict. Now, the first thing we want to do is we want to get the point at which the user clicked. And for those of you who don't remember, that's stored in the L param in your Windows message structure. So all we do here is we pull the point at which we're dealing with out of the structure. Oops. At that point, we go ahead and we ask the control itself if it has a window or not. Now, remember when I was telling you about windowless controls? By default, we have a windowless control, but if the container does not support the windowless interfaces, in other words, if it does not support the OC96 standard, we'll gracefully degrade and give you a window. Now, that all sounds nice, but what ends up happening is when you're trying to draw elements or use elements on your screen, and it's a windowed or windowless control, the coordinate systems will be different. Let me explain. If you have a window, if you have your own window, your coordinate system will be based from 0, 0 for your top left corner. But now what happens is when you have a windowless control, in effect, you are given the window of your container to use. And if you're using the window of your container, its 0, 0 coordinate will not be your control's 0, 0 coordinate. So this can save you a lot of time. So what we do is we check is window. Now, one of the things I'm going to do here, the compiler has now become a little bit more strict in terms of defining scope on operations. Now, this is a Windows SDK function that we're using, and so I want to type in : Now, for those of you who have not seen 6.0 before, here's one of the new features we put in. It's called, well, I call it autocomplete. Sometimes we call it IntelliSense. And essentially what we do is we bring up all the list of applicable goodies, if you will, functions, macros, whatever, that you can use, and then you can select one and use it. In this case, I already know it's window, so I'm just going to hit escape and continue on. Now the next thing we're going to do, excuse me? The question is, why are we overwriting? We've got the mouse position on the input. Oh, in this case, what we're doing, let me explain to you. If we're in a windowless control, our coordinate system will be based on our containers and not on our controls. Okay. So all I'm doing here in this code is I'm just offsetting that code back to 0, 0. It's easier to base a hit testing system off of 0, 0 than it is off of some random coordinate space. So I'm just taking a little bit of a shortcut. Now, the next thing I do is I go through and I calculate, or I keep what I call a bounding rectangle, which we'll implement in a moment. And essentially, from that bounding rectangle, I go through, and this should be fairly similar code to the previous one. I spin through all my elements, and then I use the pointInRect function to see if I've actually hit inside a circle or outside of a circle. Now, in the case where we do, I put a message box up, say I clicked in or I clicked out. Now, one thing about this, we also have to change our message box function. And let me give you another feature here that we have. Whenever you hit open paren, it'll come up with the parameter list of the function. We'll also do this for templates, as you'll see in a minute. This can be very useful, especially if you don't remember all the particular inputs. In this case, we're going to use a null h-win. It's going to be global h-win. And I'll put click in for the text. And for the caption, I'm just going to call it my PDC test. And then for the type, it's MBOK, or just an OK. Now, one thing, for those of you in the back, you probably can't see this, but in the front, as we scroll through the different parameters, it'll make the different parameters bold as you're typing them in, so you'll know which one you're currently dealing with. We also deal with overloaded functions, a lot of different things. If you're kind of curious about a little bit of trivia, when we first pulled, every year we have a review with Bill Gates to see what the product is doing, and we showed him that we were thinking about doing this. The VB guys have been doing this for a while. We said, yeah, we should do this with C++. And Bill and some of the others kind of came back and said, this is going to be really hard. We don't think we can do this. We actually went ahead and implemented it. It turns out it's really hard because you have all those window functions, all the C++ object functions, template functions, whatever. It turns out we have to have a very, very fast algorithm to sort through that incredible list in any reasonable amount of time. Of course, it will help if you have a faster machine. But so it may not look like much when we show up, but behind the scenes, the code on there is rather impressive. Now, what I've done here is I've copied and pasted the message box for our click, in the case where we click outside, and I just called it click out. Now, let me switch over to my slides again. Now, remember that rectangle I was telling you about? We have this MRC cuddle rect up here. That's our bounding rectangle. Now, normally I could use the rectangle given to us by the system, but this allows me to show you a little example of how you can override one of our ATL methods. This can be very useful to you. Now, all you need to do in ATL, because we mostly inherit from all these classes, is you just go ahead and enter the method definition that you're going to use and override it. But, as we'll see, if you want to return a default value or default processing, it can get a little tricky for the syntax. So I'll show that to you as we go through the demo. Now back on the demo, I'm going to go ahead and add a variable, and this is just going to be a simple rect, MRC cuddle rect, and then protected. Okay. And what I'm going to do is I'm going to add in a handler for this. And let me move this over here a little bit more space. And it's a standard method, and it's set object rect. And it takes two parameters. Now, if this is a mouthful, it's just on the IOLA in-place object window list interface. Say that 10 times fast. So you have an LPC rect, and this is going to be our position of our rectangle, which is what we'll use. And then it also handles the one that we aren't going to use, which is the clipping rectangle. Now, in our particular example, what we want to do is we want to grab the current position rectangle and then offset it to 0, 0, just in case we're in a windowless control. So in this case, I'm going to first call copy rect, and you notice as I type this in, it scrolls through that list. And if I hit tab, it'll just go ahead and finish it for me. And then we're going to type in MRC cuddle rect, that's the destination. And then PRC pause, that's our input. Now the second one is going to be offset rect, and this is going to move us back to 0, 0 coordinates. So this is MRC cuddle rect again, and then it's minus MRC underscore RC cuddle rect, and that's going to be left, and minus MRC cuddle rect, and that'll be top. One of the nice things about that parameter list is it will tell me dx then dy, so I never have to remember if it's left and top or top and left. Now, at this point, all we've done is we've copied the rectangle, but we really don't want to provide any more default handling. We want our, in this case, we want the ATL implementation to do the rest of the work for us. So what we're going to do, in effect, is return a base class call here. Now, this one gets a little bit fun. Return IOLA in place object window list impl. Remember, interface plus impl. And now here's the trick. Left paren, and notice how the IntelliSense comes up and tells us what our type name is. We want the class that we're using. So in this case, I think it's CPDC test. The reason is that for a templated function, you need to know the class to which it is attached. If you don't put that in, you'll get a compiler error. At this point, I can just go ahead and hit : and notice how the autocomplete's nice enough to come up and tell us which methods are available. I'll do setObjectRex, and then PRCPause, and PRCClip. So remember, basically the thing that you do is you call the impl function, but don't forget your class name. Let me just make sure that I got the right class name there. CPDC test. Good. Okay, let me go ahead and build this. Okay. I'll bring it back up in the test container. And now, keep your fingers crossed, you get a click in message when I click inside the circle, and a click out message outside of that circle. So, pretty straightforward. What we want to do now, though, is we want to go back to the slides, and I'm going to add some methods and properties and events. So we're going to customize the control a little bit more. Now, this should probably be fairly familiar, so I'm going to move through this section pretty fast until I get to events, because the event handling has changed quite a bit within our code. So the first thing we want to do is add in a property that will set the number of circles. Essentially, it's going to be tied to that m_n elements variable we entered earlier. Now, if we look here, there's let me go over here on the demo, and if you look down at the bottom, there's a little lollipop there for the interface for PDC test. That was created for us by the ATL object wizard. And if I right-click, it'll let me add a property. My property type will be short, and the name will be elements. And I'm only going to implement a put function. I'm only going to allow you to set this. This is more just for time than anything else. I'm going to go ahead and hit OK, and that will go ahead and specify the elements. Now, if I go ahead here up to my class, you'll see another lollipop representing the class's implementation of that interface. If I go ahead and click on that, it'll take me right to the implementation. Now, there's only one thing I want to show you here in this particular piece of the demo, and that's how to handle repaging or forcing a redraw whenever you're in a windowed versus windowless control. Now, the first thing we're going to do here is we're going to check the new val parameter. And specifically, if it's less than or equal to 0, we're going to return invalid_arg. For those of you who were watching earlier in that onDraw code, we divide by m_n elements. So if I passed in 0, I get a divide by 0 error. Also, if I passed in a negative number, what does that really mean for the number of circles? Right? So in this case, we're always going to have it be a positive non-zero value. Now in this case, I'm going to go ahead and set our data member, which is m_n elements, to the value, and then here's the thing you want to remember. This function, fireViewChange. Now, for those of you who are familiar with MFC, you're probably familiar with the invalidate control function, and that repaints the control, but only if there's a window. Now, if there isn't a window, it turns out you go through some different interfaces to actually force the repaint. In this case, the fireViewChange will take care of both situations, the windowed and the windowless. So rather than writing all that code, just call the fireViewChange and it will force a redraw. Now, the other thing I want to do is add an event. This is probably the biggest or best change if you use connection points in Visual C++ 6.0. The reason is we have made it a lot less necessary to look at your IDL file. Let me go ahead and do that. First thing I'm going to do is I'm going to show you all the way up at the top of this class view. You'll see on the right side, we've got an _IPDC test events. That was added in because we clicked on support connection points. And essentially what happened is, by default now in 6.0, we give you your own outgoing or event interface. Previously, you had to add this in by hand into your IDL file. So this saves you a lot of time. Secondly, it works just the same as any other interface. So I'm going to go ahead and add two methods here. One for click in That's what we're going to use this for. And I'm going to specify two parameters, an X and a Y parameter based on the point at which we're clicking. Hit OK. And I'm going to add one more for click out. And also have an X and a Y. I'll hit OK. This will work, this method will work regardless of whether you're using an active control or just a regular simple control using connection point interfaces. So this will save you a lot of time. All you have to remember is in the Attributes tab, just click on Support Connection Points and you'll have one of these interfaces created for you. Now one thing to remember, I'm going to go ahead and bring up the IDL file just to show you what we've added. We've added this in for you, but by default, we give you a disk interface, an automatable interface. The reason for this is more for compatibility than anything else. If you want a custom interface, in other words, something that doesn't use automatable data types, then you'll need to go through and change this both here in the declaration and then down in the code class. If you look down at the bottom of the file, you have a code class, and you want to change that from disk interface to just interface. Okay. One way to tell if you need to do this, if you go ahead and type your parameters in for your methods or for your event methods, in this case click in and click out, if you typed in something that was not automatable, in other words, it could not convert it into a variant data structure, it will give you a compiler error in the IDL compiler. In that case, if you still need to use that interface, you'll go through and change it to a custom interface. That's the one thing I'll tell you about there. Now, to make all this work, I'm going to go to my file view, select my IDL file, and compile it. It's important because we need a type library to actually implement the event interface. And this one's kind of funny because most of the times, a wizard or something will create the declaration for you, and you provide the implementation. In events or connection points, you provide the declaration using that add method, and we provide the implementation. In this case, using a proxy generator. Let me show you how that works. Now, go back to your class. Remember, all the nice things here are based off your class. Right-click, and you'll have an implement connection point now. This is a very handy little tool because if you go ahead and click on it, it will go out and find your events interface, and you go ahead and click on it, and just go ahead and hit OK. And what it's going to do is create a class for us and also hook it up to our control. Let me show you the class first. It's called cproxy and then underscore IPDC test events. And all it's doing here is it's taking the parameters, putting them into the OLE automation disk param struct, which is down here, and calling the iDispatch invoke method off of the iDispatch interface. Now, this will also handle, if you notice here, they'll have a for end connection index. If multiple containers wish to receive information from you, we'll handle all of that multicasting for you. All you have to do is just call the event function within your own application. Now, the other probably bigger thing is we go ahead and equip this up for you. First of all, we include the header file that we created. Then we go through, we inherit from that class now. And then the one thing I always forget is up here in I provide class info 2, we change one of the parameters to point to your event interface. Now this is important because some applications will use this I provide class info 2 interface to actually determine what your control will do. I believe DB is one of them. Because you specify this parameter, or the template parameter, it will know that you have an event interface. Don't count on containers just going through and QIing or even calling the connection point interfaces to determine if you support a particular connection point or not. The last thing that we do is we hook all this up in your connection point map. And all that means if someone does use the connection point interfaces, it will list this particular event interface as your as available from this control. Let's go ahead and use this. In our on L button down code, what I'm going to do is I'm going to change our message boxes to use our new methods. And the first one is fire click in. And I'm going to use my point hit structure. And then the second one is fire click out. Now, if I build this, hopefully everything will come up okay. Okay. So let's go ahead and run this. Now, the one thing I'll point you to is the lower, on the right-hand screen, there's a little split window down there. Look at the bottom of the split window. If our events are going to work, the information will be coming up there. So I'm going to insert a class. We have our function. Let me just enhance this. If I click on it, you'll see down at the bottom it's adding in an event. It's just receiving the event and printing it out. So click in, click out, whatever. Now, if you remember, I also had those that property for the elements. I'm going to go ahead and set it to the test container to 10 and invoke it. And we've changed our number of elements just to show you that we can do that. So at this point, we have a relatively full-featured control. But let me talk a little bit more about some of the other things you might want to do. Now, the next thing you might want to do is to add a property page to your control. And this is useful if you want to add some sort of user interface, say in this case to set the number of elements. Now, by default, we do not give you a property page. The reason for this is that it gives you about 4K of added code size. Most of that comes from the dialog to contain your property page. So it's a rather expensive operation. And of course, adding in additional property pages increases your code size. Now, by default, we handle all the stock property pages for you. So like that foreground color has its own associated property page. Now, if you want to add these in, what you'll do is you'll go back and look over here and go to your COM app wizard and actually, let me just do this. You'll go back to your object wizard and you'll select the property page. Where do I have it? There it is, up here. And basically that will add that into your project, and then you'll go ahead and basically what you'll do is you'll implement an apply method, which generally what that means is you'll at that point grab information from the user from that dialog box and push it in, usually using OLE interfaces or COM interfaces to your control. Now I'm not going to implement this in this particular demo because there is a bug that I will tell you about as we get to composite controls. Now, once you've implemented your property page, all you need to do is, if you look over here, there's a property map, and all you'll need to do is add that in. Now, generally what you'll do is you'll put a prop entry macro, and that will describe which property you want to set. And then the diff ID, and if you want to remember what your diff ID is, go back to your IDL file for the property. It'll have a little ID open paren like 1 or 2. That's your diff ID. And then the last thing you'll do is pass in a class ID, and that class ID is from the property page that supports it. That will basically hook all of that into your control such that when the user requests to see all of your property pages, that will all be tied in as valid properties. Now, let me show you something new. Composite controls. This is probably about the biggest request we've had from active controls. And there are two things that we've done here. First of all, we've created composite controls, but we made things a little bit more generic, and we provided some minimal windowing functionality for you through ATL. And if you're interested in learning more about that, 6.0 there's a lot of documentation on that. And essentially what it allows you to do is create very small and lightweight windowing capabilities. We added that in to handle the dialog portion of the composite control feature, but you can also use it for other means as well. Now, what I'm going to do is create a new project. Let's switch over to demo. And I'm going to create a new project here. And I'm just going to call this PDC comp. for composite control. Click OK. And I guess I'll just change anything there. And I'm just going to create another DLL. Click Finish. Click OK. And what I'm going to do here is I'm going to bring up our ATL object wizard. And in our controls, you'll notice we have our composite controls, either regular composite control or a light composite control. Again, I'm going to use the full one so we can use it in both the text container and in Internet Explorer. Now, if I go ahead and click on Next, it will look very similar to a regular active control. And I'll just call this one My PDC Comp. And for attributes, again, you can support whatever you want. Now, this time, though, supporting connection points. If I click on this, which I will, this is useful if the composite control itself wants to fire events to its container. You do not require this if you want to receive events from other controls. So remember, in this case, this is your composite control firing events, not receiving them. And I'll show you what I mean here in a little bit. And at this point, for stock properties, whatever, I'm just going to leave that blank. Go ahead and click OK and generate the project. And you'll notice we have a resource dialog come up. And this represents our control surface. And if I right-click on the control, it will allow me to insert the control. And in this case, I'm just going to go ahead and insert the one we already created, the PDC. And you can see the control comes in there. And now, if I go over to the control and right-click on it, you'll see a thing for events. If I click on it, it'll go ahead and bring up the same box that we used for the Windows messages. But now look at the bottom right-hand side. You'll see an object to work on, and that's IDC PDC Test 1. That's the control we just created. And you'll notice when I did that, up in the left-hand, it displayed our events. So what I'll do is I'm going to add a handler for each of these. And I'll just call them click in and click out. And what this will do is just give us a stub to handle our particular events. So if I go ahead and edit one of these, it'll take us to some code. And by default, what we do is we create a COM variant for you that you can go ahead and return an error code if you wish. My stuff isn't going to be that exciting, so I'm just going to remove this and put it in my own interface. And what I'm going to do here is I'm going to add a message box, just like we did before, but this time it's going to read container. All right, so I'll just call it composite. Click in. And then I'm going to call it composite control. And then MB OK. And then here I'm just going to return SOK because there's nothing much we're doing in this particular method. I'll copy that out. And I'll go ahead and do a click out with the other one. And let's go ahead and build this. And what we should be able to do now is when we insert the composite control, the different control, we insert the composite control into our test container, and we then move over to the first control that we created. When we click on it, we'll get a message box back saying that the container has received the message. So in this case, the composite control is receiving events from the active control. Let me go ahead and bring this up. Edit. Insert. And let's see. My PDC comp class, that's a composite. Go ahead and click OK. And when I click on this, I now get the message. So what's happening here is, at the upper level, our first control that we created is receiving that WML button down click or message. It's processing that and then firing a regular connection point event, which then our composite control catches and then turns into a message box. So generally, when you're using a composite control, you will deal with your child controls, if you will, through events. That's generally how you'll work with them. So you always want to take a look at which events they're supporting. Now, one thing. Remember how I told you there was a bug before? It turns out that if you insert a user's property page into a regular control and then try to bring it up in a composite control, they'll get a GP fault. Hey, nobody's perfect. In fact, I was the one who found the bug when I was getting this demo ready. That's pretty annoying. If you are interested, we have a workaround for it, and it's basically 2 lines. And if you want to know what that is, you can go down to the booth at the trade show tonight, and either myself or Mark Kramer, who's another guy from our team, will be there, and we can show you where to make the fix in your code. Essentially what it is we're not handling one of the particular composite, or I want to say container messages that we might receive when instantiating a control. The end result is we're calculating an incorrect size and trying to do some work with it, which goes down the tubes. It's about 2-line fix, and Mark can show you what's going on, or I can show you tonight a little bit after, if any of you are interested in that. But just a word of warning, a stock property page is okay, but a custom property page that you create using our wizard will not work. So that's an important thing to know. Now, where am I here? Good. Let me talk about a couple other things before I finish up. And these are kind of some other things that you might be interested in knowing. If you are interested in learning some more about these particular topics, security, licensing, and data binding, you might look out on http www.vcdj.com. And it's the Visual C++ Developers Journal. And I've got an article pinned up there now for about a year or so, but it talks a little bit about how to implement licensing and things like that. Let me kind of quickly explain what these things are for. Now, the first thing is internet security. How many of you have ever downloaded a web page only to have that little frustrating dialog come up that says, this control is not safe for scripting or not safe for whatever? Boy, some of you don't get around. Get that all the time. Basically what that means is that the control is not considered to be safe and that it hasn't been tested and validated. Now, there are a couple things that you can do to get rid of that while also providing security. Now, one thing we do for you is we implement an interface called iObject Safety, which is defined by the Internet Explorer. Now, we provide an implementation of that defines support for the iDispatch interface. So if the container asks us, is the iDispatch interface safe for scripting, we'll say yes. You can go ahead and override the methods in that to support additional interfaces. But one thing I'll point out, the IE guys kind of came back to us and said, well, you can do this, but it isn't really the greatest way of ensuring security. And in fact, we'll kind of let you get part of the way with that. The reason is that anybody can go override that interface and put whatever interface they feel like is safe for scripting or instantiation, whatever. So it's kind of just a quick check from IE's point of view. What they'd rather have you do is to cabin sign your control, and to do that you want to look in the Internet SDK. And essentially how that works is you'll get a certificate for your control, and you can get a test certificate using the SDK. But when you want to go ahead and, say, ship this commercially, basically, I think the company's Verify is the name of the company. They'll go through and give you a real certificate that you'll use with the particular control. Then, of course, you'll want to go ahead and cab that, put that all in cab file to make sure your control downloads and instantiates correctly. One nice thing to remember about cab files, about a 2-to-1 size reduction. So that's kind of a useful thing. And cab files work from HTML pages just like objects. You just put in the cab file for your HTTP or for your source tag, and it'll still work. Go ahead and bring up the cab file. Second thing is licensing. This is probably only of interest to those of you who actually ship commercial controls. In this case, you might want to have the ability to only have registered users use your particular control. Well, the way that you can do this is in your control, you'll go ahead and use a thing called declare class factory 2. Now this macro, if I just go into my first control here, just goes anywhere in the control, And I'm not going to go through and implement it, but I'll just show you kind of how it works. Just punch it in, declare class factory 2, and it's going to take as a parameter a name of a class, in this case called like see my license. And in that class, you're going to implement the standard licensing functions. I believe verify license, is valid license, and regular query license or something like that is the third one. You'll go ahead and implement those functions, and normally you'll probably validate that against a registry key that you'll do on a proper setup. You might do that against a file on the machine, whatever scheme you choose. Basically, you can validate whether that user has permission or not. Now, the last thing that you can do is to do data binding. And there are two types of data binding. There's simple data binding and complex data binding. For simple data binding, we have a class that we implement for you called iPropertyNotifySync CP connection point. It's like an event interface. In fact, I believe it gets created by default when you create your control. Now what this is, your control works just like a control, but say it's tied up to some sort of data source. Your container basically is told by the control, hey, I'm about to change a particular property here, would you like me to go ahead and do this? The container then goes out and validates with the data source that it's able to do this, and then lets the control know, yes, you can go ahead and do it, and then the control affects the change, and then sends another piece of information to the container saying that it has changed the first method. Now this requires a lot of work on the container side to handle all the controls, so it's only really useful if you're creating a very purpose-built application. In the case where you want a more generic, basically I can take this control, dump it in a DB form, I can dump it in MFC dialog, whatever you feel like. You'll want to use a complex data binding. Now here, this is a sample you may want to write down. The sample in the 6.0, and it's called complex DB. And if you're interested in how to create a complex data-bound source, that's how you do it. It uses the old OLADB consumer templates, which is part of the ATL stuff I was telling you about earlier. I'll talk about that later in the week. But it basically shows you how to go about creating a data-bound control that can handle a number of different events and basically looks a lot better to the user. So those are the kind of a couple of things. Security is always important, probably the first thing you want to do after you've got your control working, but you can also think about licensing and also general data binding if you want to hook up data sources. One last point before I let you go. Just because ATL does a lot for you does not mean that you can't go ahead and screw your control up. Always watch your code size, and specifically, small changes in your code can make a big difference. Because of that, we have made one change to ATL that you might, in 6.0, you may want to be aware of. In fact, I know Jocelyn ran into this the other week. Let me go ahead, and I don't remember where I put this anymore. Let's see, is it here? Yeah. Okay. Now, I just created a simple control here, and in that control, I put an offending function, and I'll show you why it's an offending function in a minute. In this case, I'm using an sprintf. This sprintf is part of the C runtimes. Now, it just so happens that this function requires that the C runtime initialization code be executed. What that means is it adds about 25K to your code size. One function, 25K. Wow, that's a pretty big price. So one of the things we've done in 6.0 is all of your release targets now in ATL will define a macro called ATL min CRT, and specifically exclude the C runtime startup function. Now, if I build this, I've got this set to release min size, but if I build this, it's going to give me an error. And if you ever run into this, you'll know what has happened. It will give you an unresolved external for underscore main. That means we tried to find the C runtime code and we couldn't find it, and we're just going to go ahead and give you an error. You get an error for that, it's just ATL's way of trying to say, are you sure you want to use this extra 25K worth of code? If you need it, go into your project settings, in your C++ and your general, and remove the ATL min CRT macro. Better, though, is to find a Windows alternative that doesn't require that. Guess what? WS printout. Use Windows, open some files, and go ahead and link, and there we go, right? So that's one thing that we do to help you with your code size. Always pay attention to it. Math library functions are especially bad. Other things you can do, always help your container out. Be windowless if you can. It can save as much as 30% when instantiating your control. If the container doesn't have to give you another window, you run that much faster. Finally, always try to pack as many controls as you can in one DLL that relate to each other. It's easier to do one load library than a number of load libraries. So with that, a lot of new things that we've done in ATL. Composite controls, a little bit of windowing. There's also a lot of things that we've done in 6.0, especially along the lines of connection points. The bottom line, though, is if you want to create small and fast code or small and fast COM components, ATL lets you have a great start. So please do check out the new features in ATL. And at this point, I'll thank you very much for letting me present to you today. And if you have any questions, I'll just be right outside here in the hall on this side. Thank you.